Good evening. Today we shall talk about electricity, which is for Middle 3 students, Unit 2. When we talk about the electric current, we know that it's a flow or a movement of electrons in a conductor. A conductor means a metal, like, for example, copper or iron or aluminium or so. Before we talk about the electric current, let's remember together the structure of the atom. In the middle of the atom, there was a nucleus. In the nucleus, there were positive protons and neutral neutrons. Around the nucleus, there was imaginary pathways, just like the imaginary pathway of the Earth around the Sun. But this imaginary pathway in the nucleus, they are called energy levels, and in them, electrons will rotate around the nucleus. We know that there is an attraction between the positive protons and the negative electrons because they are equal in number. Okay. If the electrons, for some reason or another, were able to overcome the attraction of the protons, then they would leave the atom and move in a metal. So they would make a flow of electrons. They would form what we call an electric current. Why will the electric current only be formed in a metal, not in a non-metal? Because in the outermost energy level of the metals, there will be 1 or 2 or 3 electrons, which will be easy for them to leave the atom. Now there are many measurements for the electric current. But how can that happen? Let's imagine a person. There are many measurements for the same person. His height in centimeter, his mass in kilogram, his body size, the size of the clothes he wears, and none of them contradict with the other. They are all measurements for the same person. The same, in the electricity, there are physical properties which have different measurements for the same electric current. Number 1, we have what we call intensity. Number 2, we have what we call potential difference. And number 3, we have what we call resistance, and we shall talk about each one in detail. Before we talk about each one in detail, let's look together at a simple circuit. For the electricity to move in a wire, the wire has to form a complete circuit. It has to be like a circle. It has to be closed. If any part of it is open, the electrons will not be able to move. The simple circuit will contain a battery. Remember, the copper part is the positive, and the base of the battery is the negative rod. A key you can open or close the circuit. You can control the flow of the electricity. The wires in which the electricity passes, and a lamp. This is a simplified way to draw a simple circuit, but this is the diagram that we use at school. The battery is a long rod and a short rod. The long rod is the positive, and the short rod is the negative. The key, the wires, and instead of drawing a lamp like that, we shall draw what we call a resistance, which looks like a zigzag, because inside the lamp itself there is a wire which forms a zigzag and forms a resistance for the electricity. Okay, now let's go to the first measurement of the electricity. The first measurement will be the intensity of the electricity. The electric current intensity will mean the amount of electricity that passes in the wire, but we have to choose a unit time, not in any time, because if you measure the amount of electricity that passes all through the day, it will definitely be more than the same amount of electricity that passes in a second or in a minute. So the electric current intensity will be the quantity, which means the amount of electric charges flowing, passing through a cross-section. A cross-section is like this. If you consider that this is a wire, cutting it sideways, this is the cross-section of the wire. Passing through the cross-section of a conductor, a wire, in 1 second. Remember, we said that we have to use a unit time. There is an instrument to measure the electric current intensity. It is called a meter. A meter comes from the word ampere meter. Ampere is the unit of electric current intensity. Just like the centimeter is a unit of height, and just like the kilogram is a unit of mass, the ampere is the unit of intensity. and putting the two words together, ampere meter, an instrument that measures the amperes, we will come out with the word ammeter. It's symbolized with a circle with the letter A on it. This is how it looks in nature, but this is how we symbolize it in drawing. How will I connect the ammeter in an electric circuit? This means, how will I put the ammeter in the electric circuit to measure the electric current intensity? This is the normal circuit as we saw before. Here, the same circuit. I will cut the wire here and I will connect the ammeter. The positive of the ammeter with the positive of the battery, and the negative with the ammeter with the negative of the battery. How do I know the positive and the negative of the ammeter? They are written on it. Okay? This way of connection, the electricity has to pass through the ammeter every time it passes through the circuit. This method of connection is said to be series connection, just like a series, just like a serial that comes on television. This is a series connection, which means that the electricity always has to pass through the ammeter. And this means that if the ammeter is not working, the lamp will not light because the electricity will not be able to pass through. A part of the circuit will be considered opened, so the lamp will not light. Okay, the measuring unit, of course, we know it is ampere. In definition, let's see at first the triangle of the rule to find out intensity. Intensity equals quantity of charges over time. Intensity is symbolized with I, quantity of charges has the symbol Q, and the time has the symbol T. When you divide the quantity of charges, all the amount of charges, by all the time, you will come out with the quantity of charges in 1 second, which is the definition of the intensity. So, I equals Q over T. I equals Q over T. The unit of Q, quantity of charges, is coulomb. The unit of intensity is ampere, and the unit of time is second. These units are agreed upon. We cannot change them. It's something that we learn. So if I want to find out, as a problem, if I want to find out the intensity, I will divide the quantity of charges by the time. If I want to find out the time, I will divide the quantity of charges by the intensity. If I want to find out the quantity of charges, I will multiply the intensity by the time. I can use this triangle for problems, and I can use it for definition of intensity. Define intensity, I will cover it. This is what I'm going to define. I'm left with 2 spaces to read. It is the quantity of charges in coulombs that passes in 1 second, unit of time. But what about the ampere? If I want to define the ampere, what is the ampere? It's the unit of intensity, or it is the intensity. When is the intensity only 1 ampere? When 1 coulomb passes in 1 second. So I have the 2 definitions and the problem solved from the same triangle. Let's talk about the potential difference. The potential difference is another measurement of the electricity. Before we say the definition of the electric potential, if you have a hot object, I will symbolize it with A, and a cold object, both made of metal, I will symbolize it B, and you approach them together or you connect them with some metal, you will find that the heat will move from the hot to the cold. The same with the electricity. If we have 2 electric conductors, conductor A has got high electric potential. High electric potential is the same as high electric pressure, but we use the word potential when we talk about electricity. We will use the word pressure if we talk about water, for example. Conductor A has got a high electric potential and conductor B has got a low electric potential. if we connect them together, the electricity will move from the conductor of high potential to the conductor of low potential. This is number one that we will find. The electricity will move until they both have the same electric potential, or until there is no potential difference. So the third point that we conclude is that the electricity will move due to the potential difference as it moves from high potential to low potential, and if the potential difference is zero, there will be no flow of electric current. This will make us talk about the definition of electric potential. The state of A is high potential, so the electric potential of A is high. The state of B, or the condition of B, is low potential, so it has low electric potential. So definition of electric potential will be, it is the state, which means the condition of an electric conductor. Why am I always talking about a conductor when I talk about electricity? Because this is how the flow of electricity will be. If there is no conductor, then there will be no flow of electricity. The electric potential is the state of an electric conductor that shows the transfer of electricity to, of course, to the low, and from the high, when it is connected to another conductor. So if the conductor is high, the electricity will come out of it, from it. If the conductor has got low potential, the electricity will go to it. Okay? Yalla. Okay, so we will talk about the second measurement. الفirst measurement كانت إيه يا أولاد؟ كانت electric current intensity. The second measurement will be potential difference. إحنا قلنا إن the potential difference is the force that makes the electricity move from high to low potential. The definition of potential difference, it is the value of the work done. يعني electricity دي بتعمل work to transfer a quantity of electric charges of 1 joule between two poles of a conductor. يعني from one pole to another pole of a conductor, if you move 1 joule, you will do a work of 1 joule to transfer 1 coulomb across a conductor. The instrument used is the voltmeter. Why? Because the unit of potential difference is volt. So the same, it is voltmeter, it is an instrument that measures the volt. It's a circle with a V in the middle. It has a positive side and a negative side. It will be connected to the electric circuit in what we call parallel. I will remind you that the circuit we had before for connecting the ammeter, where we cut the electric wire and we put the ammeter in series. وقلنا هنا إن الكهرباء غصب عنها لازم هتمشي في الأميتر، وغصب عن الكهرباء ماشية في الأميتر دي is called series connection. I want to measure the potential difference between these 2 points. هوصل ال 2 points دول outside the circuit with the voltmeter. It will measure the potential difference between the 2 points. برضو نفس الكلام. Negative of the voltmeter with the negative of the battery, and the positive of the voltmeter with the positive of the battery. This is what we call parallel connection. I want you to understand very well the difference between the series connection and the parallel connection. السيريز connection الكهرباء غصب عنها ماشية فيها. البارallel connection بره السيركت. يعني إذا كان الفولتميتر مش شغال اللامب هتنور عادي. إذا كان الأميتر مش شغال اللامب مش هتنور. تمام؟ Let's look back at the triangle through which we measure the potential difference. W and V and Q. We call it the Wivik triangle. The potential difference والunit بتاعته volt. I always put the unit in a circle. W يعني الwork. و Q يعني ال quantity of charges. اليونت بتاعت ال quantity of charges هتبقى coulomb، واليونت of work هتبقى الجول. The same التراينجل ده I can use to solve a problem. لو طلب مني potential difference I will divide the work by the quantity of charges. طلب مني ال work هعمل multiplying لل potential difference by the quantity of charges. لو طلب ال quantity of charges هعمل division لل work by the potential difference. خلي بالنا ان انا عندي 2 triangles اقدر اجيب منهم quantity of charges. كان عندي هناك التراينجل بتاع الكيت Q و I و T. If I have a problem in which I'm asked about the quantity of charges حسب اللي مديهوني في المسألة، لو مديني الورك والفولت هستعمل التراينجل ده، لو مديني الانتنسيتي والتايم هستعمل التراينجل ده. طيب الديفينيشن بقى بتاع البوتنشال ديفرنس من التراينجل، غطي البوتنشال ديفرنس. It is the work done in joules to transfer a quantity of charges of one column. دايما اللي تحت على اليمين بيبقى ب1. طب الفولت هشيل ايدي. الفولت is the potential difference. امتى يبقى البوتنشال ديفرنس ب1؟ لما يبقى الورك ب1 جول and the quantity of charges is 1 column. اهي definition of the volt والرول وال solving the problems. بس في هنا قايل 2 definitions زيادة، الجول والكولوم. الكولوم it is the charge transferred by a constant current of 1 ampere in 1 second. اهو امتى الكيو دي تبقى ب1 كولوم؟ لما تبقى الاي ب1 والتي ب1. يبقى الكولوم is the quantity of charges when the intensity is 1 ampere and the time is 1 second. طب الجول مختلف بقى شوية. It is the amount of work done by a force of 1 Newton moving an object through a distance of 1 meter. دي لازم هنحفظها لأنها different شوية. والproblem